So far, we've been talking about how to convert between moles and mass and moles and numbers of things or representative particles. So where this really starts to become a problem is that when we deal with a chemical compound that is in the form of a gas. So gases are very difficult to weigh or to obtain their mass in a laboratory setting, but we still might need to know how many moles of a gas that we have. So there are two different things that actually affect the volume of a gas. It is both the temperature and the pressure. So if we are to, heat up a gas, it tends to expand or its volume gets bigger. If we cool a gas, it shrinks. But the amount of gas that is there doesn't change. Same thing with pressure. If we apply pressure to a gas, if we push on it, it will get smaller. If we relieve pressure from that gas, it'll get bigger. So the volume can change based on these two things, but the actual amount or the number of moles you have doesn't change. So for this period of time, what we're going to do is we're going to assume that a temperature and the pressure of a gas is at a standard level. So we say under the conditions of standard temperature and pressure. And standard temperature and pressure is listed on the front of your reference tables, but it is 0 degrees Celsius and 1 atmosphere of pressure. And we abbreviate this by saying STP. And so for our purposes now, we're going to assume that gas is always at this standard temperature and pressure. And we know that 1 mole of any gas at standard temperature and pressure occupies a volume of 22.4 liters. And we call that the molar volume. Now keep in mind that standard temperature is 0 degrees Celsius. A lot of times people want to think standard temperature is room temperature, but it's actually the freezing point of water. Okay, so now we have this equality between moles and volume of a gas at STP. So I'm going to do a couple of examples in order to show you how to make the conversion and use unit analysis to solve for molar volumes. So let me go ahead and open up the Elmo and we'll do a couple of examples. See if we can get it started up here. Okay. So let's say that we have carbon dioxide and we have 4.59 moles of carbon dioxide. So let's say if you have 4.59 moles of CO2 at standard temperature and pressure, how many liters, or what is the volume of that gas that you have? So we always start by writing what we have. So 4.59 moles of CO2. And I know that my conversion factor is that 1 mole of any gas is equal to 22.4 liters. So I want to go to liters, so I'm going to put the liters on top. So there are 22.4 liters of CO2 gas per every 1 mole of CO2. And that's going to cause this mole and this mole to cancel. And then I just need to punch in, grab a calculator here, and I would say 4.59 multiplied by 22.4 gives me 102.8 approximately liters of CO2 gas are in 4.59 moles. Okay, let's just try one more. So let's start with liters and then go to moles. So let's say you have 5.67 liters of oxygen gas at STP. How many moles do you have? So in this case, we're going to start by writing what I have. So 5.67 liters. And remember, oxygen gas, oxygen is a diatomic, so it would be O2. And then I'm going to use my conversion factor here. I want to go to moles, so moles will be on top. And I know that 1 mole of O2 is 22.4 liters of O2. So my liters of oxygen will cancel, and I'll be left with some number of moles. So I'll just take 5.67 and then divide by 22.4 because it's on the bottom, and I get 0.25 moles of O2. Okay, so very simple going from gas volumes for our purposes now, because we're going to make that assumption that the gas is at standard temperature and pressure and therefore always has a volume of 22.4 liters.